So rational exponents, if you looked in your book, the book gives you 9 examples in this section. All right. So basically I'm probably gonna give you 10, 12, 15 examples today, just so I cover as much as possible. Obviously I can't give you everything, but so you're gonna have to think a little bit beyond what I tell you, but let's see. I'll kind of go through what's calculator friendly and what won't be for the test, because you will have some no calculator stuff on the test here. Okay. So can I rewrite that as a radical?
Yes.
What is it? Okay. Do you know how to type that in a calculator?
625.
Okay, so that's one option. Yes, thank you. Okay, one option. There also, so you have to type the 4 first, because it's a 4th root, and then go to math, and it's number 5, x root. So that inserts the 4 into the radical. Okay, and we should get 5. It will do you well on the test to know 1 through 5, at least up to the 3rd power. 1, of course, is easy. 2, I have no boundary on what I would ask you to know without a calculator on 2. 2 to the 10th, you can count by, okay, like yesterday. 3 to the 3rd, 3 to the 3rd is 27, 3 to the 4th, 81. I'll go up to there. 4 cubed is 64. Okay, and then 5 cubed is 125. So know those up to kind of those boundaries without a calculator. Okay, but that one I would probably throw on the calculator friendly part of the test. Okay. It's going to seem a little bit like we're just bouncing around, but these all deal with rational exponents. So lots of ways. Okay, that's one way to do it. So
can't you just simplify the 27 to 3 squares? When you simplify the field, cancel out the squares.
okay, so there's one option. The other option, sometimes you can't do that and it doesn't come out nice. So if that doesn't come out nice, because that's the easy way, Brandon says, is this what you told me? Right. So the square root of 9 is 3. So we have 3, and the root 3's are left. Okay, what's root 3 times root 3? 3, 9. Okay. Yet another way, I mean, you could write it. Okay, one thing you must know is that a square root is to the 1/2 power. It's the 2, right? So the 2 goes in the base of the exponent. Now you can add the exponents, right? Properties of powers, because we have the same base. Okay, they all give you the same answer. But.
Wait, I don't understand how you did that.
Okay, the square root is to the 1/2 power. So now we have a similar base. 1 plus 1/2 plus 1/2 is 2.
Oh,
Properties of powers from yesterday.
I don't understand that way. Now we can do this and have an exponent on it. Right.
Right, to the first.
Yeah, I always do
Yeah.
that.
It's implied. So get this one in your melons. 1/2 power is √3. What's to the third power? And the fourth power, fourth root, etc. Okay, so make sure you have those. Make sure you got that down. That will play big next year in calc. Trust me, big, big. Very cosmopolitan. Thank you. Somebody burped. You know, Cosmo's like the fashion mag for high class women. Burp, very cosmopolitan. You get the satire there. Never mind. Thank you, Doc Holliday, for providing me with ammunition. All right, where are we at? Okay, so you're going to run into these. Again, it's just manipulating properties of powers with a rational exponent. The third goes to both of them. Remember, multiply them. What's the cube root of 27? And a squared, right?
Wait, how come you made it 6?
It's a to the 6th times 1/3. Remember, exponent to an exponent, you multiply those. 6 times 1/3. Oh, that's going to be, make that a 6. 6th root of 8x to the 12th.
No, something like that.
So again, just, I don't know why it took me a while to get this straight, but the exponent goes in the top of the fraction, the root goes in the bottom. I know we've done 5 examples already, but it helps to remember that. So that's 12 over 6. This one is a little bit different. Can you do anything with it in its present state? Okay. The x, okay, the x is x squared, right? Can I change the 8? You're going to do some base changes here. Can I change the 8 into a base of 2? 8 is 2 cubed, right? 2 cubed to the 1/6 is, yeah, 2 to the 1/2, which is the square root of 2. Okay. So sometimes you're going to have to manipulate those to simplify it. Okay, what else is there? Are you with me? Anybody have any questions? Alrighty then. 243 to the 4/5. There are lots of ways to do this one. This is a nice calculator problem, right?
Yay!
Yay! What if you don't have one? Boo! Boo! Okay, I'm confident you can do that on the calculator. So if you don't have one, here's the clue. We want to get rid of that 5. 243 is something to the 5th. No. 3. You there? So 1, 2, it's 3, 9, 27, 81, 243. 5 of them.
So it'll be 80.
Multiplying by 3 every
So
time.
then you multiply
Yeah, and what's 5 times 4/5? 4. Because 5 and the 5th cancel out, right? So 3 to the 4th is 81. Right.
I know.
Properties of powers with rational exponents. Yes, this was the battle to the death yesterday on who could do these ones the fastest.
But 2.
Yeah. 5 minus 5/3 minus 2/3 is 3/3, right?
Equal to what?
Yep. 27.
How is it equal to 1?
3 divided by 3 is 1.
Oh, I thought that was 5. 5
Okay, let's see here. 4th root. So sometimes it'll say write as rational exponents. Sometimes it'll say solve, simplify, write as a radical. Okay. Lots of different ways to say things. The exponents, yes. So remember, that's to the 1/4, right? Oh, S. Yeah, my 5s are kind of blended with my S's. If I was to work on one piece of my writing, that would probably be it. Write your 5s like 5s.
So why is that 1/4?
Because it's the 4th root.
We just do 165.
That's one. That's okay. 16s to the 12th. Sorry, that's not a 5. Yeah, that's definitely needs cleared up. Okay. What's the 4th root of 16? 2. That's one of those no calculator ones.
And then S is third.
And you got it.
Yay!
It's an S. So do my 5s need to be more defined? versus my S's.
Maybe put like a slash through your S.
Like a money
That's
sign?
yeah, basically like a money sign for your S, so we know.
Okay. All right. Let's. Here's the opposite of that one. Write it as a radical.
Is that a 5?
Yes.
Okay. Is that?
We just talked about this, didn't we?
Yeah, but.
Little habit. Notice what did we have in common here? Common denominator. Yeah. So we have to get a common denominator before we go back to the radical. Okay. Yeah, 4. So 5. Right. And then 4th root x cubed y squared.
I knew the 5 was on the other, but it doesn't have an X.
There's no exponent. No, it is not. This would be written like this if that was the case, but it's not. All right.
So you just cancel out the 4s?
No. They become the root.
Oh, I see that.
Right. Yeah, things don't just disappear in math class, contrary to popular belief.
My brain does.
Brain cells. Brain cells are actually built in class.
Too much helium.
Brain cells are lost with some of the new recreational uses we have of certain items in this state. It's the color of your book. Black? Yeah, might as well be. Okay. Excuse me for being frank, or Mr. Arthur. The last part of this is learning how to solve equations with exponents in them. You guys know how to do squareds and cubed. You just square root or cube root it. How would we start this one? So, whoa, info overload, one at a time. Yes, okay. Step 1. Yes, thank you for knowing Algebra 1.
That's 616, right?
That's 616 if 6 over 65. That's this 6 weeks. Okay, well, okay, now it is. like, what are you talking about? Oh, okay.
So how do I get rid of a 4/5?
What's it?
4/5 it? You can't 4/5 it. It would make it 16/25.
No, you have to multiply by 5.
Alex has it, and so does Brandon.
I do.
Yes.
Raise it to the 5/4. Because if you multiply those two numbers, what happens? You get 1. The only question is what's 625 to the 5/4? 4th root of 625 is 5. 5 to the 5th, 3125. Can we not? I know, right? Welcome to math class. I don't know how to spec properly, but I sure can add. You get it?
Yes, I get it.
Ability to speak does not make one intelligent.
Apparently, politicians.
That was a Star Wars quote. One person in the room got it.
Who said it though?
Ooh, that's a good question. Okay. It's about as far as we need to go. Exactly. You have the work that I gave you yesterday, but I'm going to write it down again. The what?
What was the quote?
I spec.
What? That was the quote?
Yeah, Jar Jar Binks. He was trying to say that because I speak, I'm intelligent. And Obi-Wan says, the ability to speak does not make one intelligent. Or Qui-Gon, that's right. He was the younger one. Oh, boy, that's going to get him far in line. All right, you have 20 minutes. A lot. Again, I can't show you everything. I could show you 20 examples and it would cover most of it, but you just kind of have to go through. Keep your power properties in mind and how to use rational exponents. Okay? Homework.